So it occurred to me that I don't really do intros or outros on the videos that I make. And one of the reasons why I don't is I usually don't know where I'm going to be at in a particular build. So I have, like, let's say 2 hours worth of video on the construction of this up until this point, which obviously it's not done yet, but it's about probably as far as I need to get for, the first part of the video. So this is probably going to be a 3-part series, I'm guessing. The first video will take us through where we're at now. The second video should finish up everything as far as hardware, with getting the stepper motors mounted, etc., getting the water table done, etc. And then the third part of the video would be the electronics and hopefully getting it to run. So that's where I hope to be. I'm hoping that 3 videos will cover everything. The main goal in this build is to get the entire thing built for approximately $1,000. So where I'm at now with it, I'm still under $1,000. And when I say under $1,000, that's counting the metal, the ball screws, the linear rails, the stepper motors, the electronics, the drivers, etc. It doesn't cover anything else I still may run into, and it doesn't cover the plasma cutter. So one of the reasons I don't want to include the plasma cutter in the price is there's such a huge variance, whether it be a couple $100 plasma cutter or several $1,000 plasma cutter. Obviously that's all going to depend on the builder and what they do. And chances are, if you're going to tackle building your own CNC plasma table, you probably already own the plasma cutter, versus somebody who has a different interest for needing a plasma cutter, a CNC plasma cutter, for, like, say, doing small production or something like that. They are probably going to buy the plasma cutter specifically to have a CNC plasma table. But my guess would be that person's probably going to buy a commercially available CNC plasma table. All right, just getting started on the plasma table build. So I didn't really record anything with starting off the square here, because I mean, not really a lot to it. And actually I cut it, I started to weld it, and then it ended up being larger than I wanted. So I came up with a different idea on how I'm going to get it to fit. So I cut it and re-welded it, and I think I'm happy with it now. So basically, this parts washer won't be here, but it's going to fit in this area right here, with an inch or two to spare on either side. And it'll actually stick out from the wall flush here, so just about 3 feet, which of course will stick out a little bit further on this side, but that's okay. And then it's going to be on casters anyway, so worst case scenario, if I needed to move it for whatever reason, since a completed table will probably be a couple £100, it'll be easy enough to move on those casters. So just got the main box of it done. These pieces you see laying here are the legs. I got them cut pretty nice and clean, as good as I can get on my chop saw, to nice 90-degree angles. So those are going to get welded in 24 inches a piece, which seems kind of short, but we're going to put casters on it, so that's going to add 4 inches, so that'll be 28 inches. The table itself is 2 inches thick, so that's 30 inches, and that'll be a pretty good height for, if you're using heavier, thicker steel that you're trying to cut with the plasma cutter. You don't have to lift it up to, chest height or even waist height necessarily.
Ooh. Yikes! Wasn't paying close enough attention.
Okay, I didn't record it, but it was basically to get to this point where we just got these rails just initially mounted. All I did was I took a caliper, locked it in place, ran a center scratch down the whole length of the tube. Did the same thing on the other side. I know they're not perfectly machined surfaces because they're just steel tube, but should get us close enough in the ballpark. Clamped the rail in place and drilled a hole at either end and tapped it just to hold it in place. So now when I look into the open holes, I can still see the center line scratch, and just gonna use one of these punch pins and just get them centered up as good as I can. Pop, 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 pop. Do the same thing on the other side. Then we'll take these off and drill and tap. All right, I forget where I left off, but just in case I didn't cover it, just a quick update on where we're at. I got to pick up some proper washers for this, but these screws are a little bit, bolts are a little bit too long. But got these two uprights made. This beam running across is just temporarily sitting up on there. I was trying to get an idea on the length I needed, but we got these two uprights made. One on the other side, same setup as this, and really nothing to it. Just tack these two together for a 90. Bolted the vertical to the linear rail, and then on this side, since the set already has the lead screw mounted, I can show you how that works. So still need to drill the holes here in this plate, but that will bolt. That's gonna be vertical, holes facing down. I'm gonna mark this off now, get that bolted in there, and then obviously we gotta get the lead screw on the other side. Once we do that, I think the idea here is to weld a couple plates on top of this vertical piece, and then that will have holes drilled in it, and then that will bolt to the actual gantry running across. And then that way, if we have some discrepancies on height or whatever, we can always add some washers, stack them in there, and get everything squared up nice. All right, a little bit of a design change, and the reason I did it was, well, a couple of reasons. So I've already cut the ball screw down to size to be the same length as the table. I could have cut it even shorter, and then the stepper motor could have been, either the stepper motor was going to be sticking out beyond the table, which kind of defeats the purpose of having the table a certain size to stay within a certain envelope, or I could have cut the ball screw even shorter so that the stepper motor is inside the profile of the table. But then I'd be, and I really wouldn't be giving up much in the way of cutting, because, let's see here, get this the other way. Because you figure, so this 2x2 will be on top of here, and then that would be mounted on the 2x2, just obviously up higher. But you would end up with And obviously then the torch, almost dropped the damn thing. Then the torch is going to be sticking out from there. So you wouldn't give up much in the way here because you'd be able to fit the motor there. But what I originally had was a second piece that came out this way at a 90-degree angle and was going to mount to this piece, but oriented like that, facing down, right? Well, one of the things I didn't like about it was it was going to interfere with the clearance of the water table, because just a small portion of that was going to be sticking out, maybe about that much, and that was going to kind of affect the design of the water table. And I don't really want anything encroaching on that area inside of here, unless it's significantly lower than where the water table is going to go. So all I did was I cut the 90 back off of there, which, you know, I was able to save and reuse this bracket again, which that's kind of why it's really at the absolute edge here. If I had gone with this design from the get-go, I would have made another ½ inch or so longer and wouldn't have been quite this tight. But this way, the ball nut and also the truck for the rail are in the same orientation, bolts right on there from the front. And then I think what I'm going to do here, because with the stepper motor, I want to keep want to keep it from anything hanging out outside of the envelope of the table itself. I'm going to fold it back in on itself. This will be mounted on a plate approximately here, and then all I'm going to have to do is pick up some pulleys and a timing belt, and then that'll be the adjustment that we're going to use in order to drive it. And then that way too, the stepper motors are well within the confines, and they're kind of tucked in out of the way, and definitely low enough that it won't interfere with the water table at all. And I can have enough room, I could put some shielding and whatnot around them just to protect them from any kind of splashing. But that's kind of where I'm at. So the point of this whole build is to do it for as cheap as possible. But honestly, the cost to buy a couple of timing pulleys and whatnot for stepper motors is not going to be a lot. Maybe I'll end up having 25 bucks into it or so. So just for the better design setup, I think it's worth spending an extra couple dollars. Okay, here we are on the other side. Now, as you can see, I temporarily mounted up the ball screw to the plate and drew it in about as far as I could against the bearing block. And the reason for that is so that we get it the most straightest, the most stable that we can. So it can still rotate, but obviously it's not really wiggling anywhere. So it looks like it's standing proud, but it's actually not. It's slightly behind the 2x2, if you can see that. So what I'll do now is we will get a transfer punch up in there, get a mark on it, drill it and tap it. Just one screw for right now. And then we'll take this to the other extreme end. Down here, I have this one clamped in what is approximately straight. And we'll do the same thing. So when we bring it in pretty close to right to the end, it'll get everything centered up. We'll clamp it again, transfer punch, get it out of the way, drill it. One of the other things I'm going to do too while I'm waiting on parts is Gonna be replacing all this stuff with better Allen head hardware. This was just some stuff I grabbed from Tractor Supply, which, I mean, you could do it for, if you really want to keep everything nice and cheap, but it's really not that much more expensive if you get a little bit better stuff, especially if you just get it from eBay or something. You can get some Allen head hardware for probably the same money or very close to it. Okay, so a slight change of plans yet again. I'm actually going to be elevating the gantry with these small pieces of 2x2. I was just going to use a piece of like 1/4 inch thick flat stock, but I think we're going to be better off with raising the gantry even higher because I have tons of adjustment. The piece that I bought for the Z-axis is longer than I probably needed, so I'll have plenty of adjustment to bring it down lower if needed, but not really a lot to be able to go up. So the higher I make this gantry, the better. I just didn't want to design it super high up because you know, obviously it's going to be add instability to it because of, well, for racking, and also just obviously the higher it is, the more momentum it's going to be. So I want to keep it relatively low, but I think just those 2-inch pieces will be good, because then what will happen is we'll weld these on to the uprights, and then we'll drill them and tap them, and then we'll have bolts accessible from inside the 2x2 that go up into the gantry beam, and then those can be adjusted through the threading or by adding shims